This video is about how to work with splines and the graph editor while we're animating in Maya. So first of all, I'm going to navigate to File, Set Project. I'm going to find the splines folder that you have access to on the CMCO coursework server. I'll click Set, and then I'll do File, Open Scene, and I'll find the ball test version 01 here. Now what we have is just this ball moving from left to right. It only takes about 40 frames, so I'm going to trim my time slider down to about 45 frames to give it some space. And if you highlight the main control here, that's really the only one that's animated. You'll see that from frame 1 to 7 it's animated at a hold, and then from 7 to 32 it moves, and then from 32 to 39 it holds again. So let's say if we were in stepped mode, if we just finished our blocking, our animation would look like this, where it would just jump back and forth between all of our main keys. So if we're ready to jump into spline mode and we want to work with our curves and not be in stepped mode anymore, first of all it's good to make sure that your animation preferences down here are set to, I prefer auto. You can choose flat or spline. The difference being is auto has a nice smooth feel to it, and it does its best to kind of add the slow in and slow out, and it's just easier to work with in my opinion. Spline is also very smooth, but it tends to overshoot a lot of the keyframes, and then flat just has, I'll show you in the graph editor, but it takes every keyframe and just flattens out the curve. So I'll put these all at auto, hit save. Now even if we change our preferences, the animation we did is still in stepped mode. So what we need to do is convert our keyframes into a different mode. So there's one really easy way to do that. If you want to convert all of them, you can select all of your keyable attributes, double click your time slider down here, right click hold, go to tangents, and say auto, and it'll convert all of your keyframes into auto. Now we're going to go into our window, animation editors, graph editor, and see what we got going on here. So I'm going to hit F just to frame all of the keyframes. And we see here is all the motion. So if I were to go back to my viewport and scrub back and forth, you see this red line here that shows us the time, and then the curves are the translations, the rotations, all the attributes that we had keyframed. In this case, the only attribute that's really keyframed is the main control ball and translate Z. Now a nifty feature in case you don't have two monitors, or in case you don't want to spread your viewport thin like this, if you want to just look at your graph, if you hold the letter K on your keyboard, you can left mouse drag your time slider, and it'll work the same as if you were dragging down in this time slider. Now some settings to make sure you have available to you in your graph editor would be, if you go to view, sometimes people like to change this tangents from always to on active keys. I think by default it's on active keys. What that means is if we select keyframe, these purple controllers here, and if you highlight them turn yellow, those are tangents. That's how you change the angle of your curves. You can scale them, you can break them, and you can rotate them. If you have it on view tangents on active keys, it'll only ever show them on whichever keyframe you have selected. If you switch it to never, they'll never show up. If you switch it to always, then they'll all show up. If you have a lot of keyframes and a lot of splines to look at, it can be quite overwhelming to have it on always. If you've only got like one curve here, sometimes it's good to always have them on so you can kind of see, okay, this is how they're moving, and I can just see them all at once. So I'm going to leave it on always for this exercise. Also, in our animation preferences, by default we should have our weighted tangents checkmarked, but in case it isn't, or in case Maya glitches out occasionally, we can turn that on under curves, weighted tangents. Now I'm going to go over the different types of curves that we have access to in Maya, in the graph editor here, and they're really the tangent types. So the curves are just Maya's way of interpreting how the motion happens in between our keyframes. So right now we're in auto, and you'll see that auto is nice and smooth. If I move the tangents around, things tend to move with it on auto. If I were to convert these to linear, then they would be nice and flat, and then it wouldn't move very smoothly. But it would be, if you wanted like a constant speed, you could switch it to linear. Flat mode, well, it's hard to see because there's not a whole lot of keyframes, but it'll always make this tangent flat no matter what. You can, of course, rotate it, but if you remember when it was auto, it was shaping itself on purpose, as opposed to flat. We'll just make it nice and flat. Stepped mode, right here, that's what it would look like when it's just showing you your key poses. Basically, it's saying to the computer, don't move until the next keyframe. So I'll make sure that I have either nothing selected or everything selected, and I'll click on this auto tangent to make sure it goes back to the way that I want. Now, understanding how math works sometimes can be useful. So you might learn, either in physics or in some math classes, unit over time. So that's how the graph editor works. On the axis down here, our x-axis, that would be the time. So you'll see from frame 1 all the way to frame 39 here, that's our time, the frames. And then from the y-axis, the up and down, that's the units. So in our case, the translate z, that would mean 0, it's not translated at all. Down here at frame 32, it is translated at negative 20 point whatever. And everything in between, it's changing over time. When the tangents are flat, it's not changing. When it's sloped, it's either accelerating or decelerating. When it's constantly at one angle, it's at a constant speed, and vice versa. So what we can see by looking at this curve, we can see from frames 1 to 7, the ball is not moving because the translate z is staying at 0, and you can confirm that by scrubbing back and forth in your time frame from 1 to 0. And then from 7 to 15 or so, it is slowing. It's slowing in, which means that it is speeding up, essentially, or slowing out. Sometimes you get the two confused, but basically it is acceleration. So one of the main principles of animation is slow in and slow out, and that means that objects take time to speed up, they take time to slow down. So what we see in this curve, as I said before, it is speeding up. It starts off slow, then it gains some speed, and then roughly from 14 to 22 or so, it's at a constant speed. So the ball is no longer speeding up or slowing down. If it were a car, it would be at a stop. It would hit the gas, go from 1 mile per hour to 5 miles per hour, and then from this time frame over here would be at 5 miles per hour the entire time, and then roughly from like 24 to the end, 20 or 32 here, it would be slowing down as if you hit the brakes, and then from 32 to the end, it's at a standstill. So we can adjust our curves, which is very nice, if we want our object to speed up faster, slow down slower, or to do all sorts of different things. In our case, we want this ball to feel realistic. Now by default it's in auto, so it's already going to be somewhat realistic. It's going to take time to speed up, and it's going to take time to slow down. But we want to really kind of nurture that a little bit. So in this case, I'm going to let it take even longer to speed up and slow down. So I'll select this second keyframe, and if I hold shift and middle mouse drag downward, it'll lock up and down, and I'm just going to move it down just a little bit. So if I were to zoom in on these two, you'll see that there's not a huge difference in them. So it goes from 0 to negative 0.184. So what that means, and I might move it down a little more, that means that it's never going to be at a complete standstill. It'll just start off really slow, and then it'll continue to build speed, speed up, go to constant speed, and then slow down. I'm going to do the reverse right here, where I select the keyframe, shift, middle mouse drag up, and make sure you have your move tool selected, W on the keyboard, and I'll move this up just a little bit here. So now if we were to zoom out, and let me turn off, I'll switch to tangents on active keys so we can just see our curve here. We'll see that the ball will very, very slowly speed up, and then start to gain more speed, and then it'll speed up to its constant velocity, and then slow down, and then just come to a crawl until it eventually stops. So if I hit space, if I hit the play button here, you'll see that it looks a little more realistic. And you can adjust the timing too in the graph editor in case you want it to take longer to speed up. I can select the key, hold shift, and middle mouse drag left or right. So if I were to do something really crazy like this, the ball is going to be almost completely standing still for the longest time and just barely inching forward, and then it'll start to speed up, and then it'll go really fast and travel a very short distance until it starts to slow down again. So I'll minimize this and hit play, and you'll see what it does. Alright. So I'm going to hit undo and show you how a few different things we can do here. So that is the principle of slow in and slow out. Other options include fast in and fast out. What that means is that the object would not take time to speed up or slow down, but it would rather start instantly or slow down, or rather come to a stop instantly. So let's say you kick a ball. If you kick a ball, that ball isn't going to, start off really slow and then gain speed because it was at rest, and then you apply force to it, and that force is going to transfer to the ball, and it's just going to take off. So I'll select this key right here, and first of all I'm going to keep that hold. So I'll select the second key, and up in this box here I'm going to type in 0 and hit enter so that it holds, and then I'm going to turn this tangent into a linear tangent, and I'm going to break it with this button right here. And breaking it will allow me to move each side individual of each other. Now by making it linear, you'll see that there's no longer a curve here. So that ball is going to be not moving, not moving, not moving, and then boom, moving. It's not going to take time to speed up. It's just going to be moving. And if I want to really make it dramatic, I can make this curve nice and strong there. So it's just going to, in such a short amount of time, it's going to move a huge distance. But I'll keep the slow down here. Now what we'll see is it'll be as if the ball was kicked and then start to slow down. And I might want to adjust the slow down to be a little more realistic. Maybe I don't want it to pick up so much speed, but I want it to slow down more over time like this. Minimize it. And there you go. That's like as if somebody was kicking the ball and then it comes to a stop. That's realistic physics for being hit. The reverse is true if the ball hits a wall. So I'm going to take this control and I'll flatten it out, and then I'm going to join the tangents together so that they're back like this. And I'm going to treat this ball as if it is slowly speeding up. Switch to auto tangent, and then it'll hit a wall. Okay, so I'll pick this second to last key. I'm going to switch it to linear here, and I'll select both these keyframes and just type in -20. I'll also break this tangent. Now what you'll see is the ball slowly speeds up, continues to speed up, and then suddenly stops without any slowdown whatsoever. This is probably more realistic as if somebody was catching the ball. So I'll hit play, and you'll see it just stops instantly. And even that's not realistic for catching because the force would be transferred to whatever's catching it, but that gives you an idea of how to instantly stop an object. Now I'm going to select all these controls. I'm going to hit auto tangent again and join them. and then I'll zero out these top two and show you how we can overshoot or anticipate a movement just using curves. So if I want to anticipate, anticipating an animation is to essentially tell your viewer what is about to happen by doing an action. So a very, very simple way to do that is to take this second key here, and I'll shift, middle mouse drag it up. So now what we'll see is the ball is going to translate in one direction slowly, and then it'll translate in the other direction. So if I hit play over here, we'll see the ball will translate left and then forward, and that is an anticipation. And that can be very useful in animation if we don't have a whole lot of crazy stuff going on that we have to add a whole bunch of extra keys. If we just want to add one extra key and then translate that key in the opposite direction that it is eventually heading, and it'll create that anticipation. Likewise, we can do the opposite on the opposite side, and it'll overshoot. So this ball will go to this keyframe here, and then it'll translate back. Now when it's slowing in and slowing out in that phase, you'll see that it doesn't look very good. It'll be as if it was on a rubber band, kind of squishing forward and slowing in and slowing out back and forth. So let's say we want that object to hit a wall. Let's try and put together what we've learned so far with fast in, fast out, slow in, slow out, overshoots, and anticipations. And I'm going to treat this ball as if it were kicked and then hitting a wall and bouncing back. So first, I'm going to zero out this control. I'll turn it into a flat tangent, and I'll break the tangent. I'll just kind of straighten this tangent out a little bit. And I want this ball to essentially be going a constant speed until it hits the wall. So I'll turn this keyframe into a linear tangent and break that as well. But because the friction on the ball will be affected, or the friction, well, as objects move along the ground, there's friction, and that causes it to slow down. I want there to be some friction, so the ball is going to slow down, but not too much, because we don't want the ball to look like it's anticipating hitting the wall, so it's trying to slow down so it doesn't hit it. We want it to look as if it's just going to keep going and going and going until it hits something. But I'll add a little bit of slow down here, just a little bit. And you kind of jump back and forth to see what looks good. But once it bounces off the wall, it's going to change direction very suddenly, and it will come to a slowdown. So we'll see what this curve looks like, and see if the animation looks like it got kicked and hits a wall. So I feel like the ball doesn't take off fast enough, so I will adjust this fast out right here to be a little more dramatic. And let's see how that looks. That looks pretty good. It starts to slow down and then hits the wall and bounces back. And sometimes you need to play blast to make sure that it looks okay, because Maya's viewport doesn't always render in real time. So I'll hit play, and I'll say, okay, in general, it's not perfect. I'd probably go in there and spend some time with the curves a little more. But in general, it looks like it got kicked, and it's starting to slow down, and then subtly bounces off the wall. So let me actually go into the graph editor again and see if we can make this look even better. So I want this ball to not take so much time to speed up. So instead of this where it's slowly speeding up, that sounds weird, it's accelerating at a slow rate, I'm going to have it accelerate at a fast rate, like this. Basically switching these curves in the opposite direction. So the ball will gain speed at a faster rate. It doesn't quite take off as fast, but I think in general it looks a little better. Kind of looks like it's on an ice hockey thing where there's not a whole lot of friction. So, you know, sometimes you just kind of have to jump back and forth and say, okay, what if I do this? What if I do this? What if I just select these two curves all together, switch linear, and just leave it completely 100% straight. What is that going to look like? That doesn't look too bad, but the ball doesn't look like it gains any speed, and it shows that in the curves. So I'll just kind of jump back and forth and see what I like. I'll just leave it like that for now. To give a better visual of this ball hitting an object, I'm going to actually create a wall. So I'll go to Create, Polygon, Cubes. I'm going to move that over, switch to my side view, and I'll find right where the ball hits, right here, frame 29. I'll move this object in the way. I'll scale it up. Just kind of place it right there. Now if I go from this view, we can get a better idea of this ball bouncing off a wall. And you can make all sorts of adjustments. You might think that it's better if this changes directions at a faster rate and then slows down not as fast. And if you'd like, you can just completely mess with these curves altogether and see what sort of crazy results you get. Like if I have it anticipate and then change direction very suddenly and then accelerate at a slow rate but then get to its location and slow down, and then it's going to overshoot and bounce back really fast. And what's also nice, we'll see how this turns out. It might look a little weird. Very weird. What's also nice is we can insert keys into the graph editor. So if we click this key right up here with a plus button next to it, and we middle mouse click on, well, you'll have to highlight your curve first. Middle mouse click where you want to put a key, and it'll insert a key there. Then I can click my move tool, W, and I can move that however I see fit. So if I just move it out here and I flatten that tangent, let's see what happens. It's going to look really weird, but sometimes it's fun to experiment. Now let's see what happens. So you'll see that the ball just goes all over the place and does some really weird stuff that doesn't really make sense. That's the gist of how to work with splines in Maya, how to insert keys, and how to use the slow in and slow out methods to make the ball look like it's speeding up and slowing down and anticipating and overshooting, speeding up. Already said that. So this is kind of a part 1. I'll do a part 2 video where we do a more complex action, so go ahead and check that video out if you're interested in seeing how to work with splines and all those principles we just used with character rig.